In this video, we are going to talk about some different methods or strategies for subtracting mixed numbers. Okay, so we've already gone over how to add and subtract fractions using the models, and so now this is just some strategies for using mixed numbers. And there are 4 different ones: exchange from the whole, using improper fractions, compensation, and adding up. Okay, so let's start off with exchanging from the whole. So let's do the problem 10 and 2/7 minus 3 and 5/7. So if I'm doing 10 and 2/7 and I'm subtracting 3 and 5/7. So this is just lining up vertically and subtracting how we would usually subtract vertically. Okay, so 10 and 2/7 minus 3 and 5/7. If I would start off by doing 2/7 minus 5/7, you can't do that because this is 2 pieces, 7 make the whole, and I'm trying to take away 5 pieces, 7 make a whole. I can't take away 5 from 2, so instead, let me borrow over here. So I'm going to change my 10 to a 9. And how many pieces does that add over here? Well, 7 pieces make a whole, so it adds 7/7. Okay, so my new problem is 9 and 9/7, because I added 7 more 7s to it. I already had 2 7s. 2 plus 7 is 9/7. I'm still subtracting 3 and 5/7. And 9/7 minus 5/7 is 4/7. 9 minus 3 is 6. So 6 and 4/7 is the answer. Okay, so basically the same idea as like if you had base 10 blocks, just breaking it down, borrowing, taking a whole, turn it into a fractional piece, and then subtracting vertically. So that's exchanging from the whole. The next one is improper fractions, and this is how upper level grades are taught to subtract mixed numbers. So if I was going to do 10 and 2, same problem, 10 and 2/7 minus 3 and 5/7. So the first thing we need to do is to change into an improper fraction. Just a reminder how to change into an improper fraction. You multiply 1 times 3 and then you add 2 to it. So like if I was doing 1 2/3, 1 times 3 would be 3, 3 plus 2 would be 5, that's the number on top, 3 stays the number on bottom. So over here I do 10 times 7 is 70, 70 plus 2 is 72, over my denominator still 7, because 7 parts still make a whole. I just have 72 total parts. Subtracting 3 times 7 is 21, 21 plus 5 is 26, 7 parts still make a whole. So 72 7/7 minus 26/7. Since my denominator is the same, I can just subtract the top. 72 minus 26 is 46 out of 7. So that could be an answer, or if you want your answer as a mixed number, just a reminder how we go from an improper fraction back into a mixed number. I divide it. So I think 7 goes into 46 how many times? Well, 7 times 6 is 42. And when I subtract it, 46 minus 42 is 4 pieces left over. So 6 and 4/7. Okay, so my answer is again 6 and 4/7. Okay. So for the third one, compensation. Before we do that with fractions, let me do compensation with whole numbers just to kind of remind you. We've kind of already gone over it a little bit. So if I needed to do 32 minus 19, like in my head with mental math, a lot of people, the way they think about it is they do 32 minus 20. I said, well, 32 minus 20 is 12. Did I take away too much? Yes, I took away 1 too much. So add 1 back in. So then it would be 12 plus 1 is 13. So 32 minus 19 is 13. Okay, so again, 20 is an easier number to subtract instead of 19. but it's taking away one extra, so you add one back in. So you're compensating for that one extra one you took out. Okay, so compensation with fractions is the same idea. So let's do the same problem. It's 10 and 2/7 minus 3 and 5/7. So the thought process here is I'm starting off with 10 and 2/7. Instead of subtracting 3 and 5/7, let's round that up to a bigger number. Let's just subtract 4. Okay, so 10 and 2/7 minus 4, that's easy to do in my head. That's 6 and 2/7. But I took away too much. How much too much did I take away? We were supposed to take away 3 and 5/7, but I took away 4. So how much extra did I take away? Well, to get from 5/7 up to the next hole is 2/7 away. So we took away 2/7 too much. So I need to add that back in. So add 2/7 back in. So my 6 and 2/7, I need to add 2/7 back in. And 6 and 2/7 plus 2/7 would be 6 and 4/7, which is the correct answer. Okay, so again, the process, taking away 3 and 5/7, I rounded that up to 4, got an answer, figured out I took away, instead of 3 and 5/7, I took away 4, so that was 2/7 too much, so you add that number back in to get your final answer. Okay, and then the last one is adding up. That's very, very similar to the missing add-in. You're just doing it with fractions. Okay, so the fourth way was adding up, which is basically your missing add-in method. So 10 and 2/7 minus 3 and 5/7 equals what? I can turn that around into an addition problem. 3 and 5/7 plus what equals 10 and 2/7? And let's do it piece by piece. So 3 and 5/7, what can I add to 3 and 5/7 to make it a nicer number? Well, 3 and 5/7 plus 2/7 gives me a pretty whole number of 4. Trying to get to 10 and 2/7, so now I can do 4 plus 6 equals 10. So now I'm at 10. How do I get to 10 and 2/7? We'll add 2/7 more. So 10 plus 2/7 is 10 and 2/7. That's what I wanted to get to. My answer, remember, is the sum of the boxes is my answer. So let me add up the boxes. What is 2/7 plus 6 plus 2/7? Well, it's 6 and 4/7. Okay, so that's 4 different ways to do the same problem. So on your homework, you'll have a few examples where you're asked to do all 4 different ways. So just refer back to the notes or refer back to the video to go over how to do the adding up, compensation, improper fractions, and the exchange from the whole.